Hi, welcome to First Maths class. Today we are looking at elective maths topic coordinate geometry 1, and the subtopic that we are going to consider is collinear points. Collinear points. When we say collinear points, there are three or more points on a line, a straight line, which have a constant gradient. So let's say when you have this straight line and you have a point P, then point Q, then point R. You realize that this point PQ, when you find their gradient and you find the gradient of QR and they are the same, it means they are collinear because automatically PR will also be the same. So 3 points are collinear when they have a constant gradient and they are all in the same straight line. So that is collinear. Let's solve some examples and see. Determine whether or not the following are collinear. The following are collinear. So A, we have 3, 2, 5, 3, and -5, -2. Then B, we have 3, -4, 2, -6, and 1, 5. So we are going to consider these points and find out if they are collinear. So we start from the first one, A. To determine if they are collinear, it means we have to find the gradient. So let's pick the first and second points and find their gradient. And we know gradient M is equal to y2 minus y1 all over x2 minus x1. So when we pick the first 2 points, 3, 2 and 5, 3. This is our x1, y1, x2, y2. So our M is equal to 3 minus 2 over 5 minus 3. So this one will give us 1 out of 2. So that's the gradient for the first one. Now let's look at the gradient for the second one, which is 3, 2, and -5, -2. This one is our x1, y1, x2, y2. So with this, our M is equal to -2, that's y2, minus 2. Then -5 minus 3. So we have -4 out of -8. And this one will give us 1 out of 2 because when you cancel, you have this. So since both of them are giving you the same gradient, it is collinear. Okay, so since 3, 2 and 5, 3 and 3, 2 and -5, that's the two different sets, have the same gradient, they are collinear. That's the first one. Let's try the second one and verify if that one will also be collinear. So second question, we are picking the first point, 3, -4, and 2, -6. So the gradient for that one, we have x1, y1, x2, y2. So y2, that's -6 minus -4 all over 2 minus 3. So we have 6 minus will be plus. So we are going to have -2. 6 plus -6. So we have -2 over -1. The answer is 2. So that's the gradient. Then we pick the second point, 3, -4. and 1, 5. So our m, we have x1, y1, x2, y2. This gives us 5 minus negative 4 over 1 minus 3. And we are having 9 out of negative 2. 9 out of negative 2. So we realize that these ones are not the same. Since they are not the same, they are not getting the same gradient, they are not collinear. They are not collinear. But sometimes there can be a question where you need to apply. You need to solve that question. Let's get one question here and see. So the question is, the point 2a and 2a, negative 2, 2, and 3a, 9 are collinear. Find the possible values of a. We are saying that they are collinear. So if they are collinear, it means the gradient of this set and this set should be the same as the gradient of this set and this set. So now let's find the gradient of 2a and negative 2, 2. So gradient of 2a or 2 comma a and negative 2, 2. So these are x1, y1, x2, y2. So with this, our m is equal to 2 minus a over negative 2 minus 2, which will give us 2 minus a over negative 4. So that is the gradient for the first one. Now you pick this and that and find the gradient. So gradient for 2a and 3a, 9, m is equal to, you have x1, y1, x2, y2. So 9 minus a over 3a minus 2. 3a minus 2. And this is the gradient for the second one. But we are saying they are collinear. If they are collinear, it means their gradient should be the same, should be equal. So it means that we can say that 2 minus a over negative 4 should be equal to 9 minus a over 3a minus 2. So the next thing is we can cross multiply that. So we have 2 minus a multiplying 3a minus 2 is equal to this one also multiply. So minus 4, 9 minus a. So we need to expand this. So with the expansion, we have 6a minus 4 minus 3a squared plus 2a is equal to minus 36 plus 4a. So having gotten that, we can continue to simplify this. So let's group them. We have minus 3a squared plus 8a minus 4 is equal to negative 36 plus 4a. So we can send all of them to this place. So this one is negative, moving to this place becomes 3a squared. 8 moving to this side becomes 4 minus 8, that's minus 4a. Then negative 4 moving to be positive, so we have minus 32 is equal to 0. So having gotten that, the next thing is for us to factorize that. And to factorize this, we have to multiply this one by that, and you get negative 96. Two numbers that multiplies to give you negative 96, but add to give you negative 4 becomes negative 12 and 8. When you multiply this, you get negative 96, but when you add it, you get negative 4. So 3a squared minus 12a plus 8a minus 32 equal to 0. So you factor 3a out. Then you are going to get a minus 4 plus this one, the common factor here will be 4, will be 8, sorry. 8 out, 8 goes here, a minus 4 equal to 0. So 3a plus 8, a minus 4 is equal to 0. So equate each of them to 0. A minus 4 equal to 0, which will give you a is equal to 4. Then 3a plus 8 equal to 0. 3a is equal to negative 8. Therefore, our a is equal to negative 8 on 3. So therefore, our a is equal to 4 or negative 8 on 3. And that gives us the solution to this question. Continue to subscribe to Francois Math Class, and you can also contact me on 0246 426343. This brings us to the end of today's lesson. Bye bye.